Good morning. My name is Tom Rummage, manager of the Applications Engineering Department. I want to talk to you a little bit today about bonding one of our new technology advanced sensor, the 125 UWA sensor, to, of course, a coffee cup with the Vishay logo or the VPG logo on it. We're going to be bonding the gauge in the hoop direction, and we're going to drop this coffee cup. And when we drop it, there's a good possibility it's going to fracture and break. And what we're looking for is the hoop strain in that direction during that fatal event. So the first thing we're going to do is we're going to start off by degreasing the part. And I'm picking the non-logo side because it'll be a little easier for surface preparation. The handle holds it stable. Take the CSM3. I'm going to saturate a gauze sponge with it. And I'm going to degrease the surface of the cup, removing any oils that my handling might have induced or anything like that. It's removing the grease and oils. The next step is we will dry abrade with some 320 grit silicon carbide abrasive paper. This allows to break the shine of the ceramic surface and give us a more bondable surface. The dry abrade is just to start hitting it and make it a little bit more rough, if you will. The next step will be a wet abrade with the 320 grit. We want to take a little of the organic contaminants and that sort of thing and remove them. Note the cup is circular, so it tends to have the materials roll off, so you have to kind of be careful with that. I'm wet abrading with the conditioner A, a mild phosphoric acid solution, again removing the organic contaminants and preparing the surface for bonding. And now we need to do with a single wiping motion, we're going to absorb the excess material and any contaminants that are there. And since I've got a big, fairly wide area, I'm going to go down here and get it all set. Alright, so we finished with the wet abrade with the conditioner A and the 320 grit. I'm now going to go to the 400 grit silicon carbide abrasive paper, a slightly finer finish because we're expecting not too high a strains. And I'm going to wet abrade with the 400 grit. And in between each step, just as we did before, I'm going to take a clean dry gauze sponge, fold it into quarters, and I'm going to absorb the excess material with a single wiping motion, avoiding dragging contaminants back into the gauging area. Next step, I'm going to take some of the CSP1, the cotton tip applicator, and I'm going to, using the conditioner A, the mild phosphoric acid solution, scrub the surface where I'm going to bond the gauge. Again, we take the cotton tip applicator, holding your finger behind it to give it a good mechanical effort. And what we're looking for is removing any contaminants, and it looks like it's coming up pretty clean. Final step with the conditioner A is to dry it. With a single gauze sponge, fold it into quarters, absorb the excess material. Now right now the pH of our surface is mildly acidic, and so we want to apply the neutralizer 5A to bring the pH back to either a nominal or slightly basic. And I'm going to repeat the step I used with the conditioner A. I'm going to use a cotton tip applicator, and I'm going to scrub the surface of my cup. Again, this is a final washing, and it gets the pH down or up to neutral or slightly basic, which the M-Bond 200 does well with. It does not do well with an acidic surface. Alright, so now I'm going to take my cup, kind of set it out of harm's way here, and I'm going to bring up a glass plate. This glass plate is going to be used as our staging area for the strain gauge. First thing with almost everything you do with strain measurement is you need to make sure your tools are clean. So I'm going to take a couple of drops of the neutralizer 5A, put it on the glass plate, and scrub that. And I'll take that moistened gauze sponge with the neutralizer 5A, and I'll clean the business end of the blunt nose tweezers. You just don't know where these things have been and whether they're contaminated. Next step is we need to open up the package of gauges. I'm going to use the blunt nose tweezers to handle that gauge. I'm going to pull it out with the acetate folder. Notice there's a shiny side and a dull side. I want to have the shiny side up. Using my blunt nose tweezers, I'm going to grab the gauge by the corner of the tabs. You don't want to grab it by the grid corner because you might damage the grid. Again, noticing that we have a shiny side and a dull side. We want the shiny side up. Keep your sunny side up and everything will be fine. Next step is to locate the PCT 3M tape. I'm going to get rid of about 2 inches of it because it might be contaminated. I'm now going to pull off a piece long enough to handle the gauge and put it on the cup. I'm going to stretch it to take the curl out. A little static electricity this morning. I'm going to fold over the ends of the tape so I have little handles to work with, makes it more convenient. I'm going to place that gauge handling tape over the top of the gauge and lightly squeegee my finger over the top of it to capture it in the gauge handling tape. Now we need to remove the gauge and put it on the part where we're going to actually put the strain gauge on the part. I'm going to lift it at a shallow angle. If I lift it at a steep angle, if I were to lift it like this, I would damage the gauge. So I'm going to lift it at a shallow angle until I'm beyond the gauge. I'm now going to move my cup into position and place my gauge in the location we'd previously prepared. So that ends our surface preparation and gauge alignment. I'm now going to expose the bonding surface, again lifting at a shallow angle until I get beyond where the gauge is exposed completely. Taking the Catalyst C, we're going to be using M-Bond 200, and it has a Catalyst C that must be applied prior to the bonding. On the inside of the neck of the bottle, I'm going to hit it 8 to 10 times. Removing most of the material, and then I'm going to, with a single wiping motion, wet the back of the gauge. Notice I lifted it beyond the gauge so whatever excess material would not be on the gauge. If you see blue, you've probably put too much catalyst. Now this must air dry for 1 full 60-second minute. Okay, we've waited our full 1 minute of air dry time of the Catalyst C. We're now going to apply the M-Bond 200 adhesive. It's a cyanoacrylate instant setting adhesive system. I have a gauze sponge at the ready. I'm going to lift up the gauge so I can manipulate it with my fingers. Take a single drop of the adhesive and put it at the cusp of the tape and the edge of the cup. Pull it taut in the direction with the gauge and squeegee through with a single wiping motion, and then follow with your thumb. And we're going to hold my thumb on here for 1 full 60-second minute. This allows the catalyst and the adhesive to cure and give you the proper bond. So 60 seconds. Trust your watch, not your head. After the 1 minute of thumb pressure and then another 2 minutes under the tape, we're ready now to remove the gauge handling tape and expose the solder surfaces so that we can do our proper soldering. Before we lift it at a shallow angle, this time we're going to go at a 180 degrees back on itself. The adhesive system is excellent in shear, but not so good in peel, so we're going to remove the tape in shear. Looks like I was successful. I'm going to make a quick visual inspection. I'm looking for any lumps or bumps underneath the grid, any perturbations in the look of the color underneath it that might indicate a non-uniform bond line. And based on everything I can see, it looks pretty good. The next step is to add the lead wire system. I have the soldering station over here set for about 550 degrees Fahrenheit for our 361 A20R solder. Take a gauze sponge. We'll use a clean, dry gauze sponge to remove the excess solder. And the iron is still warming up. And I flood the tip. What this does is does a quick cleaning of the tip and prepares it for proper soldering. I'm going to clean that off. Then I'm going to lightly tin the tip, press the solder in the target of the area, press the iron firmly through it, add fresh solder and fresh solder and flux, and remove them together. And now we have tinned the tabs of our gauge. We've now completed tinning the tabs of the gauge, and I'd previously prepared the end of this lead wire. I've twisted and tinned the black and white together and the single red by itself. I'm now going to position this over the top of the tabs of the gauge so that I can complete those solder junctions. Paper drafting tape, PDT paper drafting tape. I'll take a piece off. I'm going to place that right at the end of where the conductors begin and the insulation ends, and I'm going to form the classic cobra head, spring loading the lead wire so it'll be down into these solder junctions rather than jumping out of them. I'm going to preliminarily position it, and taking my pointed tweezers, I'm going to reposition those lead wires over the top of the tabs of the gauge, and I'm going to reflow those two solder junctions. Again, same steps. Clean the tip, lightly tin the tip, place the solder in the target area, add fresh solder and flux, and voila. You now have attached your lead wire system. I'm going to use a product called rosin solvent, and this rosin solvent is going to do two things for me. It's going to help me remove this gauge, the paper drafting tape, without damaging the gauge, and it's also going to begin the process of flux removal. So the first thing I'm going to do is saturate the area with the rosin solvent, just getting it all over the back of the tape because it's helping to break down the mastic of the tape along with the flux of the soldering operation. And once I get things pretty well saturated, I can use the bristles of the brush to remove this tape. Well, the ceramic coating really likes to grab this tape's mastic. All right. There we go. Now I'm going to concentrate in and around the solder junctions. I'm putting the flux into suspension, and then I'm going to blot that suspension away with a clean, dry gauze sponge. So get it into suspension, blot it dry. Get it into suspension, and blot it dry. We do this at least 3 times, because if you don't do this and you leave flux behind, it will be unstable, and we don't want an unstable strain gauge. Electrically unstable, I should say. And the final step is to put in a strain relief loop. I'm going to take the handle of a dental or cotton tip applicator. I'm going to use my pointed tweezers. I'll open the tweezers up, and about 3/8 of an inch to 1/2 inch away from the gauge, I'm going to slide the cotton tip applicator up into it and then rock away from the gauge, forming this nice little inchworm type shape. This is a strain relief loop. And the final step would be to take a piece of the PCT All right, I have done my GIT 1300 checking both resistance to ground and also the installed resistance of this strain gauge. It happens to be a 350 ohm strain gauge, and it showed being 350 ohms and showed me about 20k mega ohms resistance to ground. All right, our final step after doing all the GIT 1300 checkouts for resistance to ground and also installed resistance, which it passed with fine colors. I'm now going to apply the M-Coat A. It's a polyurethane material, air drying. It's laboratory conditions, environmental protection. I'm going to work that in and around the solder junctions and a little bit up underneath the tape, underneath the lead wire there, and completely cover the gauge. This is offering both a mechanical and a little bit of an environmental protection from moisture in the air. During this process, I started off using the CSM3, the degreaser, in conjunction with our gauze sponges, GSP1s, the conditioner, the mild phosphoric acid solution, the neutralizer 5A, the solution for getting the pH back to nominally neutral or slightly basic. We use the Catalyst C, which is applied before the M-Bond 200 adhesive is applied. We use the M-Bond 200 adhesive for handling the lead wires and holding the lead wires down during soldering. We had the PDT-3 tape. Once we got the gauge installed, we need to use the rosin solvent, and we did our soldering operation. We used the rosin solvent to remove any residual flux left behind in the operation of soldering. And then the final step was to use the M-Coat A. This is all based on the advanced sensor technology CEA-Series of strain gauges, the 125 UW. Basically a drop-in replacement for the old 125 UW. It's now a 125 UWA, and A stands for Advanced Sensors. Thank you for your attention. Okay, now that we've bonded our strain gauge to our cup, we're going to run two tests, possibly both destructive. The first one will be dropping it from about my head height onto carpet, and look at that signal. And if that doesn't break the cup, we're going to drop it onto a block of concrete, and likely as not that will break the cup. And we're looking for the signal during the actual failure. So John, tell me when you're ready.
Recording.
Dang, broke the candle. But the cup is still intact. Basically what we hear is the signature of that first drop on carpet. This is probably the initial impact, and this is where it hit the concrete and broke the handle. But now what we can do, because of the StrainSmart's capability, we're going to zoom in on that and have a little bit better look at those two peaks. Note now we can see pretty much that it's going to be a ringing out type situation where you hit it and then it rings out its natural frequency. However, we did not fail the cup. Oh, what's that? An anomalous behavior.
Or that where it hit the concrete.
That might be where it hit.
Get the bounce.
Yeah, it might hit the second bounce. That was where the handle fractured off of it. All right, let's rerun the test, and now we're going to drop it onto the concrete block.
Recording.
There's our broken cup. I made a mess of my nice, pretty strain gauge installation. And you can see how the strain relief loop did its job, kept the wires connected to the gauge during the failure. And the only thing holding things together right now is tape. Well, it takes an impact blow of approximately 500 microstrain to shear a ceramic. Okay, now we're looking at the signature of dropping that same cup onto a piece of concrete. Obviously we have this major spike there, that's where it hit and probably initiated the failure. And then these secondary wave down here, let's zoom in on that. Let's have a look at that. This is probably where it fractured initially, and here's where the pieces hit again, and it's ringing out after being damaged. Because it's not a uniform circular part anymore, the ringing out is not as resonant as it was before.